Hello everyone, I am live once again. I'm very sorry if you can hear some background noise. That's because in the other room there is a Super Smash Bros. Ultimate tournament happening. I think a victory just happened. But of course, I am here in this closet doing something far more boring, AP Calculus, specifically U-substitution. And in this video, I'm going to be going over this 10-question worksheet, hoping to help some people out there understand U-substitution a little bit better. Now, for our first question, e to the 3x, we got to integrate that, specifically an indefinite integral, and you know what that means. But first, how are we going to deal with this in a manner with, well, substitution? Well, first, basically, think of U-substitution as one of the methods of reversing the chain rule. So really what you want to do when you're dealing with a substitution problem is you want to pick out a part of the equation that looks like it could be considered an inner layer of the function, if that makes sense. Specifically, you'd be looking for functions in an exponent, or under a radical, or in a parenthetical with another exponent over it. And if that's confusing at all, you'll see what I mean in the following examples. But there are plenty of different cases. With the biggest one being you want to have a derivative. You want to pick out a part of a function that you can isolate that has a derivative that's equal to another part of the function. But let me just explain with an example, since that probably doesn't make any sense whatsoever. With this first question here, e to the 3x. Now, in this very simple integrand, an inner function is pretty obvious. The most obvious choice for that seems to be the 3x right here. So let's pick out that as our u. So let's say that u, and u is the variable that we're subbing in. Let's say that u is equal to 3x. Now what we'll want to do is, since if this is our u, then we'll say that du is equal to 3, since that's a derivative of 3x. And normally derivatives are written as like a du over a dx, but I didn't do that. And so instead, actually, let's put the dx there and say du equals 3 times the dx. And this is important because this is actually what we're going to be substituting. But you may notice, though, that if we were to substitute all the x's in for these u statements, then there's a constant 3 there multiplier, which that's not in the original function. So instead, let's write it as 3 times du equals, or actually 1 over 3, because we're dividing both sides by 3 essentially. So it's 1/3 of the du is equal to 1 times dx. Now you're probably still scratching your head. If you don't have experience with U-substitution, you're probably still scratching your head wondering where the heck I'm going with this. And here's where. So let's look back at our original function here, the indefinite integral of e to the 3x dx. Meaning we're integrating to x. So let's plug in what we just did and sub everything in so we no longer have these x's, and instead we have a much simpler term to integrate. So instead, since I have the 1/3 outside, we can't ignore that because the 3 is still part of the du. So I'll write it as 1/3 outside of the integral symbol, and our new function is e to the, and instead of 3x, instead I'll write e to the u, because u is equal, because we set u equal to our 3x. And instead of putting the dx here, instead I can put a du here because that includes the dx the way I wrote it, and its 3 cancels out with the 1/3 over there. So instead I'll write e to the u times du. Now that we have this is way easier to integrate now, because now it's easy to see that the integral of this is just going to be 1/3 times e to the u, without that changing at all, because of the nature of functions with an e base. So, however, obviously we still have to add a plus c, but now we can finally replace the u with what was originally supposed to be there, 1/3 e to the 3x plus c, and there's our final answer. That was a pretty easy example. Let's try something a little bit more illustrative of what we're often doing, what we're really doing with these functions. So here with question number 2, we have a trigonometric function here. And this is another good example of when you know what to set as your u. Because in the sign parentheses here, we've got a 2x. And we can tell that if we were to take the derivative of 2x, then minus the constant, we would have something pretty similar to this x right here. And once again, let me just explain to you what I mean with this example. So if we were to, again, set u to x squared, the thing inside the parentheses, then du is equal to 2x dx, or bringing out the constant, because we usually want to bring out the constant. It's 2 du equals, or 1/2 du, sorry, because we're dividing basically, times x dx. Oops, let me get that out of the camera. All right. So now, rewriting this as our integral, now we'll have the 1/2 on the outside, and now we're just finding the derivative of the sine of, and x squared is our u, so we're finding the sine of u times du. And now, once again, our derivative is much easier to find because now we are dealing with fewer terms. So now it's just going to be the half, because the constant doesn't change, whether it's inside or outside of the integral. And we know that the sine is going to integrate to a negative cosine, so I'm going to add a negative sign at the start, times cosine u, and the du is gone because we integrated. So now, we add a plus c, and now putting our u back in the negative, now we're putting the u back to x squared. Now we have a fine, satisfactory answer. So our next few examples are also pretty simple. In this case, with number 3 over here, we're just doing the same kind of thing. U equals our 2x. There's no other 2 outside here, so we're going to have basically a 2 du. Sorry, 1/2 du. I keep forgetting to do that. Equals 1 dx. So that we can rewrite our original function as the cos of the sine, of u du equals, and once again, the integration of the sine is going to be negative cosine, so negative 1/2 cos u plus c. And now, once again, we just have to sub in the u, which is just our 2x. So yeah, so those examples were pretty easy so far. Now let's try something else that isn't a trigonometric or something like a simple e. So here, once again, it's pretty obvious to see where we need to set our u, because right here we've clearly got a parentheses in the middle of this other exponent here, which is going to be pretty tough to work with without this rule. So let's say 1 is equal to 2x cubed. So our du is going to be equal to 6x squared dx, or just 1/6 du, which is now just the x squared dx. Which, of course, once again, we've got the x squared equal to this one right there. So we can once again rewrite our integral as the 1/6 of this part right here, which is our u to the power of 3. And then we can take this dx and this x squared over here and simplify the whole thing down to our du. So now we can very easily find, hey Bruce, he's watching at me through the window, find that is equal to 1/6. And using basic integration rules, we know that the exponent's going to go up by 1 and then divide that whole thing. So it's going to be 1/4, because that's what the integral, the exponent's going to change to. And the du is gone, so now it's just going to be u to the power of 4 over 24, because 6 times 4 is 24. And then I'm going to sub that in, sub the u back in, so that it's 1 plus 2x cubed, power of 4 over 24. And don't forget the plus c. Whew. All right. Question 5 now. All right. So our u, once again, it's now our u. Now we have a u under a radical. So that's another obvious thing to set that to. So our du would this time our du of that is going to be a negative. This is going to get us a -1 deriving that. So instead I'm going to put the negative on the outside without actually adding a constant over there. So now it's just a 1 dx. And now we're making the entire integral negative with this over here. That's right. And now we're just going to derive that. Integrate that whole thing, which is going to be 2u to the half, which is subbing that in and rewriting the 1/2 at the top, and the exponent is going to get us down to the square root of 4 over 6, minus 6, of course, bringing back the u, and adding c to that. And that's how you do the first half of that whole thing.